This is a video on some problems on 5.7, which are some extra practice and some log graphs in particular. Okay, so let's look at this first graph. Just kind of go through a procedure about how to approach these. So first you're asked to graph this log graph, log base 3 of 4x minus 1. And I always start with the domain and range and the vertical asymptote, if there is one. And so you know inside the log has to be greater than 0. So that means my domain is going to be all x values greater than a fourth. And to find the vertical asymptote is where inside that log equals 0. So there's going to be a vertical asymptote at x equals 1/4. And because I am going to be taking the domain of all positive values, then I know that the range of my log is going to be all reals. So let's just start there. And then find some nice points to plot, just to kind of get the idea of things. But, okay, so first I have maybe I'll do it in black, a vertical asymptote. If this is 1, let's do a vertical asymptote at a fourth. And my domain is going to be everything to the right of that. And let's see if we can find some nice points. By nice points, I mean, are there x values I can plug in that are going to be powers of 3 so that I can evaluate the log nicely? So I notice if I put in x as 1, I'm doing log base 3 of 3, which is 1. So that's a nice point to plot. So 1, 1. Let's see if we plug in a half. That means I'm doing log base 3 of 2 minus 1, or log base 3 of 1, which is 0. Okay, so 1/2, 0. And let's see if there's anything else that I can do or estimate. Maybe let's see if I put in, let's put it in 3. If I put in 3, I've got log base 3 of 11, which is between 2 and 3, but closer to 2. So between 2 and 3. Again, when I put in 3, I get log base 3 of 12 minus 1, or log base 3 of 11, which is more than 9 and less than 27. So it's going to be between 2 and 3, but probably closer to 2 there. So wait, 1, 2, 3. This graph's looking like that. Okay. So that's the first one. Now it's saying find and graph the inverse. Oh, actually, let me put in, before I forget, this was 1, 1, and this was 1/2, 0. Even though I have them on my table, I'm going to write them in too. All right, so now let's find the inverse. So switch x and y. X equals log base 3 of 4y minus 1. All right, the log piece is isolated, so I right away can jump to changing it to exponential. 3 to the x equals 4y minus 1. So solving for y, I've got 3x plus 1, and then all divided by 4. That's going to be my inverse. Maybe I'll just call it f inverse. Okay. All right, so now let's, we also can plot some points here, but I know since it's the inverse, 1, 1 should also be a point on it. Switching x and y, I still get 1, 1. 1/2, 0 will now be 0, 1/2. Oh, and another thing we should note here is if I rewrite this inverse as 1/4 times 3 to the x plus 1/4, it's going to have a horizontal asymptote at y equals a fourth, which also makes sense because if it had a vertical at x equals a fourth for the log, the inverse is going to have a horizontal at x equals a fourth. So we'll just put that in. Okay, so I've got this, blah, blah, blah. This is 0, 1/2, and 1, 1. Let's do another point. So let's do maybe so this is for the exponential. If I put in 2, I've got 9 plus 1, or 10/4, or 5/2. So 2 is going to be 2 1/2. All right, so the graph is looking like, whoops, something like this. And it should be symmetric. I mean, yeah, it should be, if I draw y equals x, it should be symmetric across y equals x, given they are inverses. And actually, they do intersect in two places. One we saw. To find the other one, you could get an estimate on Desmos, but we're not going to be able to algebraically find the second intersection. Okay, that was number one. Let's do another. Okay, let's do 3 since it looks a little weird. All right, so first thing is the domain. So I know for log, I'm putting in values where x plus the square root of x plus 5 is greater than 0, which means x is going to be greater than -5. And there's going to be a vertical asymptote at x equals -5, or inside the log equals 0. All right, so let's start there. Maybe I'll do. Okay, so putting in 1, 2, 3, 4, 5. Here's my vertical asymptote. And let's do some nice points, or try to do some nice points, I'll say. The base here is 3. So if we do, let's see, if I plug in, let's plug in -4. Oh, by the way, the range will still be all reals because I'm going to be doing the log of all positives, so I'm still going to get all reals. If I put in -4, that's going to be log base 3 of 1, which is 0. If I put in +4, that's going to be log base 3 of square root of 9, or log base 3 of 3, which is 1. So 4, 1 is another point. All right, so this just kind of gives me my relative shape there. Okay, so that's my log graph. And now let's move to finding the inverse. So x equals log base 3 of the square root of x plus 5. Again, the log is isolated, so I can change it to exponential. 3 to the x equals the square root of x plus 5. And then I can, to get that, sorry, I should have made this y, not x. Then remember, we have to solve for y, square both sides. So 3 to the x squared equals y plus 5, or 3 to the 2x minus 5. Why did I just write y? Dear Lord. 3 to the 2x minus 5 equals y. There's my inverse. Okay, and this will have a horizontal asymptote at -5. And I know I can flip the points I had before. So -4, 0 is now going to be 0, -4. And 4, 1 is now going to be 1, 4. Let's see if we can find the y-intercept. Oh, we already found the y-intercept. And, okay, so let's just draw. Actually, we have enough to just draw it. And again, it should be symmetric across the line y equals x, which it sure seems to be. Let's do one final one. Let's do 5, since this one's a little bit weird. Okay, so domain normally would be all reals, but I'm restricting it to the positives here. I'm just saying, and 0, so greater than or equal to 0. So if I'm putting only greater than or equal to 0, let's see if we can find the range here. Because the range of the exponent will be negative infinity to 1, because the vertex of that parabola is at 0, 1. And it opens down, so negative infinity to 1. And so 2 to the negative infinity is really close to 0. And the 2 to the 1 is 2. So a very, very limited range here. All right, so let's see. Let's draw this out. See if I can hone in on this area. Okay. So, and I should say that it's going to have a horizontal asymptote at y equals 0. So let's maybe draw that in. And where is it going to have that high point at? Well, when I put in 0 for x, the high will be the 2. So let's draw that, 0, 2. And let's plot some other points. So just to get an idea of what's happening. So we just said 0, 2. When I plug in 1, I'm going to get 2 to the negative 1 plus 1, or 2 to the 0, which is 1. So 1, 1 will be a point. What about if I plug in 2? If I plug in 2, I'm going to get 2 to the negative 3, or 1/8. So 2 is going to be tiny. All right, so it's going to look like that. So nice and rounded up here, and then going closer and closer. And if it was less than 0, 2, we would see it being symmetric across the y-axis, but we don't have that. So let's get rid of that. Okay. Now let's do the inverse. So switch x and y. So x equals 2 to the negative y squared plus 1. And remember, the domain and range will flip. So in this case, this was the domain for the original was x greater than or equal to 0, which means the domain, the range of my inverse will be y greater than or equal to 0. And the domain will be 0 to 2. Okay, so let's keep going here. So let's change it to log form. Log base 2 of my answer equals my exponent. And remember, we're solving for y. So y squared equals 1 minus log base 2 of x. And then we're going to square root. Now, normally we would say plus or minus, but we know the range has to be greater than or equal to 0 because that was the domain restriction on the exponential function. So it's just going to be the positive square root of 1 minus log base 2 of x. So a lot of thinking involved in this problem. Okay, so let's flip these points. We had 0, 2 for the exponential. So then we'll have 2, 0 for the inverse. 1, 1 is still going to be 1, 1. And then 2, 1/8 is going to be 1/8, 2. So up here, remember there's going to be now, there was a horizontal asymptote y equals 0. Now there's a vertical asymptote at x equals 0. Now, one thing that may be helpful here is to guide your graph is it has to be symmetric across y equals x, which may help when we graph this to see what's happening here. All right, so it's going to, back to my red. And then it should go like that. So notice, let me see if I can point this out. This red piece should line up if folded over y equals x with that black piece, and then these two pieces should line up. So that helps me to guide my graph. Because again, when I folded over that, the y equals x line, the graph should line up and be symmetric across that. So I wanted that red and that black piece to match up, and then the other red and the other black piece to match up. Yeah, so that is kind of tricky. Okay, one more. Let's look at number 9. This is not a graph. But it's not. We're going to learn when we do some laws of logs and change a base formula. We're going to learn how better to deal with this. But for now, we're going to have to use the tools we know. So we need to figure out what the heck this is. Okay, well, let's start somewhere. First, let's actually, instead of starting by setting that equal to x, remember we've done problems like this before when if the bases lined up, but if they were the same, then it's a function would undo itself. But right now that's not the case, which is problematic. But let's see if we can get them to be the same. So maybe let's just work with log base 9 of 18 and see if we can change that to be log base 3. So right now I've got 9 to the x equals 18. Or I can say 3 to the 2x is equal to 18. Or I can say 3 to the x squared is 18. Square root both sides. I'm not going to do plus or minus because 3 to a power can never be minus, so it's just going to be the positive square root. And the square root of 18 is 3 root 2. Okay, so now let's move it back to log form. This tells us that log base 3 of 3 root 2 equals x. All right, so remember what we originally had x as. We originally had x as this, but we just rewrote x as log base 3 of 3 root 2. So now I can rewrite the original problem. 3 to the log base 9 of 18 is the same as 3 log base 3 of 3 root 2, which is just going to be 3 root 2, which is pretty cool. Okay, that's it.